All right, welcome back. In this last video of the third series on polynomials, we're going to focus on factoring and finding the zeros or the x-intercepts of polynomials. So only very special higher degree polynomials can be factored. And we're going to focus on cubes, difference of cubes, and sum of cubes, and four-term polynomials that can be factored with the grouping method. So let's see how this plays itself out. So the first thing I notice when I'm looking at this given polynomial is that it's a binomial and of degree 3. And if we have cubes in both terms, that with either a plus or a minus in between, we can factor these as sum of cubes if it's a plus, or in this case, difference of cubes if it's a minus. So what I want to start to do is look at each term and write them as their perfect cubes. So I notice 8x cubed is 2x times 2x times 2x, or 2x to the third power. And 125 is 5 times 5 times 5. If you can identify these two quantities that you have to cube to get the two terms respectively, then you're going to have difference of cubes. And the first quantity is going to be our A, and the second quantity is going to be our B. And you apply the difference of cubes formula as it shows above. This shouldn't be too hard to check this rule with distribution. We're just going to use it. So I'm going to set this equal to 0 and factor the difference of cubes. So the first factor in our factoring rule is a minus b, or 2x minus 5 in this case. So I'm just plugging in the a as 2x and the b as 5. Then we have a trinomial that says take the a and square it. So 2x times 2x is 4x squared, plus a times b, 2x times 5 is 10x, and plus the b squared, 5 times 5 is 25. Then, taking your factors equal to 0, well, the first one's pretty easy because all I got to do is add the 5 over and divide both sides by 2, and I'm getting x equals 5 halves, or 2.5, as one of our x-intercepts or zeros. Since the second factor doesn't factor any further and break down further, the only thing I can do here is use the quadratic formula, which gives opposite of b, so good review problem again, plus or minus square root of b squared, minus 4 times a is 4 and c is 25, all over 2 times a, or 8. And when I calculate 10 squared minus 4 times 25, I'm getting a negative 300 under the square root, which is going to come out as an I. The negative turns to positive 300 then with that conversion over 8. And this tells me that this factor gives no additional real solutions from this factor. So it appears that there's only one real zero at 2.50. Now, as always, you should be able to take this function and graph it and verify that this is your x-intercept. So with such a small number as 2.5 for the x-intercept, I'm going to use a pretty small window for the x, something like negative 5 to 5 with a scale of 1. I notice that the y-intercept, when x is equal to 0, is all the way down at negative 125. So maybe a y window of negative 200 to 200, counting by 50s, so that we can see that y-intercept at negative 125, gives me a good hint that that might work. That's the window I'm going to try. And when I graph that function on that window, we are definitely verifying that 0 or x-intercept at 2.5. So I feel pretty confident about that answer. So the real zeros and the x-intercepts are both asking really the same question. There's one real zero at 2.50. So in this example, I'm noticing that there's 4 terms. And whenever there's 4 terms, the one standard way to factor it, if it can be factored, is going to be with the grouping method. So we'll demonstrate that here. So again, we're going to take our function, 4x cubed plus 12x squared minus 9x minus 27, set that equal to 0, and then group the terms as the first 2 and the last 2. We're grouping the 4 terms into 2 sets of 2. And then you want to look for a common factor in the first group. So just looking at the 4x cubed and the 12x squared, I'm noticing that there's a 4 common and x squared is common to both of those. And if you factor that common factor out from just the first 2 terms, we're left with x plus 3. Then going to the second group, I notice that there's a 9 common to both terms. And we'll pull out the minus with it, because all factoring is dividing out the common factor. So negative 9x divide out the negative 9 leaves me with x, and negative 27 divide out the negative 9 also leaves me with a plus 3. Then, if you've done the first step correctly, you should have an absolutely identical binomial for each group. And we're going to take that common binomial and factor it out to the front. Then dividing the first group by x plus 3 leaves me with 4x squared, and dividing the second group by x plus 3 leaves me with minus 9. Then the last thing you want to ask yourself before leaving this is, can you factor further? And it does say factor the polynomial. So can we factor this further? And looking at this binomial, I very quickly notice the power 2 and decide that this is difference of squares. So I'm going to bring the x plus 3 along and factor the difference of squares as 2x and 2x, 3 and 3, 1 gets a plus, 1 gets a minus. And then setting each factor to 0, you get your 3 solutions. So setting x plus 3 equals 0, we're getting x equals minus 3. 2x plus 3 equals 0. So we have 2x equals minus 3 after subtracting, or x equals minus 3 halves. And doing the same thing for the third factor, we're going to get x equals positive 3 halves. So it appears that we have 3 x-intercepts at negative 3, 0, negative 3 halves 0, and 3 halves 0. And again, if you graph that, you can verify your answers and determine whether your factoring was correct. So again, the y-intercept of negative 27 suggests a window for y of maybe negative 30 to 30 as a suggestion. With a y scale of 10. And we've got relatively small numbers for the x-intercept, so again I'm thinking maybe negative 5 to 5 with an x scale of 1. So let's see how that looks. So using those intercepts as guidance to set up your window surely does help, because now I can pretty easily see that these three solutions are good, because I see an x-intercept at -30, another one at -1.50, and a third one at 1.50. So my factoring looks good, and my solutions look good. So that verifies that we got our 3 zeros. All right, so that ends our study of polynomials in this second series on polynomials and quadratics. I hope you found these videos to be useful in your study of algebra. Until next time.